in this video we'll try to obtain the transfer function or the control ratio. So now I'm going to sketch the block diagram, and this is the block diagram. Here we have the input signal Rs, and then it is given to the summing operator with the positive command, and after that we have the forward block Gs, and after that we have the final output Cs, right? And in this question, this is a closed loop type problem. So now what I am going to do here is a closed loop type problem, because in closed loop, for the next signal, right, it is taking, like it is using the last output. Now this is the last output and this is the final output, right? In order to proceed the next signal, right, closed loop type system uses the previous result like this. So this is HS, and this is that final result which is coming. So this result is used by this kind of a system to proceed the next operation. So here we also call this function as the error function, right? Because now this feedback path we are using to correct or to reduce the error. So this feedback path is connected with the negative command. So now let's see how to write how to obtain the transfer function. And this is Rs, right? Because this signal comes like Rs, and this is Cs. Starting from here to here, here, it comes as Cs. Write it clearly. So this is Cs, 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 Cs. And when it is coming like Cs up to here, right, so then it needs this error Hs. So when the signal passes from here, it is going with this Hs. So the result what we have at here is Cs times Hs. Cs, Hs. So here also now what we have is finally Cs and Hs, right? So now here we have positive Rs, here we have minus Cs, Hs. So then here we have, that means after this summing operator, we have the addition of it, which is Rs minus Cs, Hs. That is what we have here, right? And then when that signal comes up to here, it meets this forward block Gs, right? So when the signal, when that signal passes after this, it is multiplied by this block, right? So then the final result at here will be Rs minus Cs, Hs multiplied by this. Here we have the desired input, and this is the output, which is Cs. So Cs is coming like this, and then it means this block Hs. Then the signal is released as Cs times Hs. So then it comes up to here. Then there is a kind of an arithmetic operation. So these signals are getting added. Then after that, this signal produces, and then it is multiplied by Gs, and that is what we obtain as the output. So now we know how to obtain the transfer function. So let's write it again. Cs is the output. It is equal to Rs minus Cs, Hs into this Gs, right? So that is what actually happening. So now let's expand this. Cs equals Rs times Gs minus Cs, Hs and Gs. So now we can take all Cs parts up to here, then we can keep Rs over there. So then it will be Cs plus Cs, Hs, Gs. Now what I am doing is I am going to take this part to here, and that is equal to Rs and Gs. So now Rs is the input. So because Rs is the input, that Rs is always greater than Cs. This Rs is always greater than Cs because now this is the input. So when the signal passes from here to there, due to the losses, the original signal, the original signal that you have over here, you will not get when you reach up to this point. So that is why we need to do this correction, because of the system losses signal will not remain as the same. So then we open up here. So then here you can take the common factor as CS. Then now you can have 1 plus GS HS, and here we have RS times GS, right? And so finally now what we have is CS divided by RS. This RS you take here, CS keep there. So here you can put GS divided by this part, which is 1 plus GS HS. So now CS divided by RS is what we define as the CS divided by RS is what we actually define as the transfer function or the control ratio. So control ratio is equal to GS, which is this forward function, divided by 1 plus GS into HS. This loop.